This is a demonstration of a thrust-vectored belly sitter model in ArduPilot running inside RealFlight8. And so this model was created by Lorbass Otto on the ArduPilot forums, and it is quite an accurate representation of his real aircraft. So I'll just get to give you a close-up look at what the aircraft looks like in the vehicle editor. So what we can see is that it's a belly sitter aircraft, and it is got thrust vectoring. So we can see there that we can move the left motor up and down, and we can move the right motor up and down, and we also have control of the left elevon and of the right elevon. So this arrangement of the motors allows it to land on the ground with the motors pointing up like that. And you can see that the motors then are out of the way of the ground. And so that's how it takes off from the ground, takes off and lands, and that's why it's called a belly sitter aircraft. All right, so I'm now going to go back into the simulator and start it again, have it sitting on the ground. And what I'm first of all going to do is just do a takeoff in Q hover mode. So we have ArduPilot connected to the Real Flight Simulator. And so I'm going to arm the vehicle on the ground like that. And then I'm slowly going to raise the throttle, and it will take off as in Q hover. All right, so there's the aircraft hovering. I'll just bring it down a little bit. That's good, maybe a little bit closer. And I'll spin it around so you can get a closer closer look at what the aircraft looks like. So you can see that it's really just a standard delta wing aircraft with a couple of little winglets on the end for your stability and forward flight. And the main difference is instead of having a single motor, it's got two motors, and those motors are vectored. They basically have two little servos that can tilt the motors forward and back, and that gives it a much greater degree of pitch stability than you normally get in a tail sitter aircraft. That this sort of aircraft is commonly used as a tail sitter. It also means that it can land on the ground with the motors tilting up. So we'll show you how a landing is done. Bring it down to the ground slowly. And it's going to touch down and land, and you'll notice that while it was landing, it automatically tilts the motors up so that they don't touch the runway. All right, so we'll take it off again, and then I'll do a forward transition so you can see what it looks like when it's flying forwards. So if I just hover it there now, and I'm going to turn on the binocular view here, and that'll make it a little bit more obvious what it's doing when it's doing a transition. And so now I'm going to put it into forward flight like that, and it's now in fixed wing flight. Now this particular aircraft, I've used the same settings that Lorbass had on his real aircraft, which included a degree of thrust vectoring in forward flight. So while it's flying as a fixed wing aircraft, it's mostly using the elevons, but a proportion of the fixed wing control does come from the vectoring the thrust on those forward motors. And that gives it a great deal of control. And you can really see that control if I tell it to suddenly flip to inverted flight, like this. And now it's flying inverted, so it can really flip over very, very fast. And that happens because it's got the thrust vectoring, so it's got an awful lot of roll control. This aircraft's already got a fair bit of roll control anyway, but that makes it even greater. All right, so now I'll show you a back transition where it's going to transition from forward flight back to hover. And so we're heading now basically straight towards the pilot's box, and there I'm going to transition it, and it's now in hover again. All right, and bring it back down. Okay, so you've now got an idea as to how it flies. What I'm going to do next is going to demonstrate a fully autonomous mission with ArduPilot. So RGPilot is, of course, a full autopilot that can do fully autonomous missions, and that allows it to do, automatic takeoffs and then transition to forward flight, fly a mission, and then automatically come back and land. So I'm just going to bring it down and land it. There it is, landed. And now what I'm going to do is disarm the aircraft and load a simple vertical takeoff mission, followed by transition and then a couple of circuits. Then it'll come back and land. So I'm going to put it into auto mode. You'll notice that when I put it into auto mode, it put up the motors to face upwards. And we're now going to arm it to take off as a full auto mission. All right, it's taking off, and it'll go to about 10 meters or so, and then transition to forward flight. And then it'll now start doing a rectangular circuit in fixed wing mode. So there it is, doing a rectangular circuit. It's set up to fly at about 20 meters. Normally at this flying field, I would fly a little bit higher than that. The reason I'm flying at a low height is in the graphics in this simulator, it is clearer to see the aircraft if it's a bit lower down. And so there it's doing a full auto mission at about 20 meters, just doing counterclockwise circuits. And I'll let it do another circuit or so. While it's doing this fixed wing flight, I can tell it during the full auto mission to fly upside down instead. And there it is now continuing the mission upside down. So there's just a switch on my transmitter I've got set up for inverted flight. So we'll let it do a circuit inverted. And then when it's on its way back up north again, I will tell it to flip over the other way. And it's now going to flip up the right way again. And there it is, doing normal right way up flight. Okay, so now that's enough sort of flying in circuits. I'm going to tell it to come back and land. So I've just put it into RTL mode, and this will bring it back down towards the takeoff point, and it'll transition to vertical flight. And now it's in QRTL mode. It's automatically transitioned to QRTL mode when it reached an appropriate distance based on the deceleration limit that we had set as a parameter. And so then what it's going to do is reposition itself above the takeoff point. And once it's above the takeoff point, then it'll start descending, which is what it's doing now. And then it'll slow down as it gets close to the ground. And then it will, let's see if it flips the right way. Yes, it did. Okay, good. And there it's going to turn off the motors because it's now completed the landing. And it's now disarmed and completed the mission. So there's our little thrust vectored belly setter in RealFlight8. This model is available in our Cittal models directory, so you can load it if you've got your own copy of RealFlight8, and you can load that and fly it yourself. It's great for getting used to this type of model. Happy flying!